The Su-57, codenamed Felon by NATO, is the fifth-generation multifunctional twin-engine aircraft. It has many advantages: supersonic cruising flight speed, modern weapons, radar-absorbing coating, and the latest set of onboard equipment. The Su-57 is the future of Russian military aviation. It embodies advanced technologies and design solutions. Super-maneuverable and stealthy, it can destroy air and ground targets, detect the enemy at long distances, and operate in network-centric warfare. The Su-57 is a versatile machine that combines the functions of an attack aircraft and a fighter. Su-57 is incorporated with 3D thrust vectoring controls that enable improved maneuverability at high speeds and altitudes. The 3D thrust vectoring control capability is also deemed to be better than that of the F-22 Raptor. It is able to fly in cruising mode at supersonic speeds. The high maneuverability and supersonic cruise capability are expected to give the fighter an upper hand in close-range dogfight scenarios. The fighter uses a built-in oxygen-producing unit. The flight time is practically unlimited because refueling with oxygen in the parking lots is not required. In terms of its characteristics, maneuverability, controllability, the Su-57 is very close to the Su-35 aircraft, but surprises it with its performance at supersonic speeds. The dynamics of acceleration near the ground to supersonic speeds is also impressive. Composite materials are widely used in the fighter. They occupy about 24% of the weight in the structure and about 70% of the outer surface area. Acoustic emission sensors will read the composite materials measurements that occur during operation. When the material wears out, there are more sound pulses. This will help to localize the damaged zone and perform aircraft maintenance in time. Strain sensors are installed on highly loaded elements. In the Su-57, radar protection is provided by a special shape, the slope of all surfaces in a clearly limited range. In addition, materials that absorb radio waves are used in the skin. Compliance with these requirements influenced the shape and design of the fighter. The decrease in radio visibility became one of the main reasons for placing part of the weapons in the internal compartments. Thanks to these measures, the reflected signal is significantly attenuated and directed away from the source. As a result, the enemy radar does not receive information about the position and speed of the aircraft. Felon has two side bays to store short-range air-to-air missiles and two internal weapon bays mounted between the engines. Carrying weapons internally will reduce drag while allowing the aircraft to maintain a low radar profile. The developers included a maximum of large-sized parts in the project in order to facilitate assembly and increase the reliability of the aircraft. Compared to the Su-27, the airframe of the new fighter has 4 times fewer parts. Su-57 can be armed with 4 beyond visual range missiles and 2 short-range missiles for air-to-air combat missions. For ground strike capability, the Su-57 is fitted with the Kh-38 tactical ground missile and precision-guided bombs. The maximum combat load is 10 tons of ammunition. The Su-57 is equipped with a fundamentally new complex of integrated avionics with a high degree of automation. At the heart of its radar system is the most advanced detection technology, an active phased array antenna, AFAR, containing 1,526 transceiver modules. This provides the Su-57 with a large detection range, multi-channel tracking of targets and the use of guided missile weapons on them. The side-looking radar allows the pilot to execute a tactic known as beaming, in which the aircraft turns perpendicular to an enemy's pulse Doppler radar array to avoid detection. It also enhances the situational awareness of the pilot. ATOL infrared search and track sensor mounted on the nose allows the aircraft to detect and engage stealth targets from distance. The Su-57 has advanced communication, target detection, and sensor fusion capabilities. Its S-111 communication system facilitates secure and jam-resistant data exchange with other aircraft, ground, aerial, and naval command and control posts. Flying as an airborne tactical network, the Su-57 can detect air defense radar emissions and share a consolidated picture and ground control for real-time engagement of active adversary radars. The concept of using the Su-57 was developed taking into account the conduct of network-oriented operations. This aircraft can work in concert with the same type of fighters and with other types of combat vehicles. The onboard equipment of the new aircraft makes it possible to exchange data in real time and coordinate actions with ground control systems as part of an aviation group, as well as perform tasks autonomously. It is being prepared to perform tasks in integration with the latest heavy UAV Okhotnik, Hunter. A flock of attack drones robots under the control of a fighter pilot can become a breakthrough in the field of combat use of military aviation. Two 15-inch screens are used to display information. The Su-57 alone is an ideal machine for military use, but the possibility of coordinated use in tandem with an unmanned attack drone increases the fighter's capabilities. Drones work on the principle of faithful wingman, increase combat power, take on enemy fire, help suppress air defense systems and save the fighter, and reduce risks for the pilot. The use of drones in conjunction with a manned fighter is one of the battlefield trends of the future. The winged drone can carry an arsenal for air combat and ground attacks, help infiltrate enemy lines and deliver accurate strikes. The Su-57 is ideal for both long-range and close combat. This distinguishes it from most stealth fighters, which perform well only at long distances. The high maneuverability of the fighter at supersonic speeds gives the Su-57 a huge advantage in real combat. Earlier in 2018, Russia officially acknowledged using 4 Su-57 during the Syrian campaign.